Twist we're going to do in 3.3 is that we're going to have variables on both sides of our equations. We stay with the same procedure, getting like terms together. We just add an extra step. Now, I would suggest always moving your variables first. It makes things a little bit easier, but remember that equal sign, especially now because you're going to have more steps of balanced equations. So the first thing we're going to do is we're going to put our variables together. Another suggestion is to move your variables to the side that has the larger variables. Then you don't have to deal with as many things with any integers or negative signs. So I'm going to go ahead and I'm going to subtract my 7n from the left because the 10n is on the right. Getting my variables together first is a suggestion. So I have negative 5 equals, and I have 3n plus 13. Now, if I get my constant terms together, I'm going to have to subtract 13 from both sides. And when I'm combining negative 5 and negative 13, I get negative 18, and that's going to equal 3n. Now I'm dividing by a positive 3. I'm dividing a negative by a positive, so that means I'm going to get a negative. And my answer is negative 6. N equals negative 6. We have a couple more with variables on both sides. And we'll go ahead and this time I'm going to move the 3n over to the left because 5n is larger. Again, there's that equal sign. 5n minus 3n gives me 2n. Minus 2 equals 6. Now I can get my constants together. That equal sign, so I can go back to my balanced equations if I need to. 2n equals 8. Divide both sides by 2, and we get n equals 4. Looking at the next one, which way are we going to move? We're going to move the variables first, and we're going to move them to the left-hand side. To the right-hand side, move the one from the left to the right because that's the larger variable. I end up getting 4 equals 3y minus 17. I'm going to add 17 to both. Big equal sign again there, showing that I'm doing some computation. 4 plus 17 equals 21. 21 equals 3y. Divide both sides by 3, and I'm going to get 7 equals y, or y equals 7. Moving to the next example, we're going to see, I guess I threw one more of the trying those equations. So we're going to go ahead and we're going to do, the 9m is larger, so I'm going to subtract m from both sides. I get negative 1 equals 8m plus 15. I want to subtract my constant term, balanced equation, equal sign there. 8m equals negative 16. And then divide both sides by 8. And then m is going to equal negative 2. Now in 3.3, we're also going to look at sometimes when there are no solutions and all numbers could make a solution. And I bet you these two examples will show us exactly that. So we see some parentheses. We always have to do the parentheses and simplify the sides first. So I'm going to distribute my 5. So 5 times 2x equals 10x. 5 times 1 equals a positive 5. And then we have 10x here on this other side. So now 10x and 10x are the same terms. So on the left side, I'm adding 5. And on the right side, the term is staying the same. So that can never work. So that is a no solution. You can do that by the equal sign with the diagonal saying it will not work, or you can write no solution. I wonder what this other one's going to be now. So I don't have to do anything to the left side here. Everything is simplified, but I have to distribute on the right. 2 times 3x gives me 6x, and 2 times 1 gives me 2. Now, if you notice, I have the same variable, and I have the same constant term. So 6x plus 2 equals 6x plus 2. That's going to be always. So the answer would be all solutions. No matter what I plug into x, since it's on both sides of the equal sign, having the same operations done to it, any value of x will give me an equal equations on both sides. And that finishes 3.3. And that is the end of the first part of chapter 3.